Hello and welcome. You might have clicked on this video for several reasons. Maybe you are new to CV2 or you know CV2 and just wanna know if you missed something. Whatever the reason is, hope this video helps. In this video I will be giving you the basic information you need for CV2. I will not be covering MakerPen usage. So if you don't know how to use it, I suggest you find another tutorial. Also, if there's a certain invention or a gadget that you would like to know how to make, or a subject you'd like for me to cover, comment it down below. So, about CV2. If you're new to CV2, you might have gotten scared by the large amount of chips. See, unlike CV1, CV2 is much closer to actual coding. Don't be scared though. Compared to coding, CV2 is much easier and more restricted. CV2 is kinda like Scratch if you ever coded in that. So in this video I'll be covering the basic information for CV2. So we will be covering executive signals, variables and different data types, and other basic information. Now, knowing CV1 can be either a good thing or a bad thing. I would suggest you throw all of your CV1 information out the window when you're dealing with CV2, unless you see something that really resembles CV1. So don't try to use the information you learned in CV1 in CV2. The main difference between CV1 and CV2 is executable signals. Now, executable signals are the things that make other things happen. They are the most important part in CV2. You can recognize this executable signal inputs and outputs by an orange arrow. As you can see, the orange arrow can be on either side of the board. When they are on the right side, that means the signal is coming out, so you can attach it to another circuit. So when it's going in, that means it's doing something to the board. Now, a lot of chips don't require an executable signal to work. For example, the add chip. The add chip will continuously output the sum of the numbers that you have input. It doesn't matter if the inputs change, the output will change with them. An executable signal can start from many places. An executable signal starts from events. Now, the event can be you pushing a button, or you going into a trigger zone, or interacting with an interaction volume. The event receiver, when you configure it, has a bunch of events that you can start the signal from. For example, here we have a 30 Hz event. That means it'll continuously output a signal. The event can also be when a player joined or when player leaves. Basically, any time that event is happening, it will send a signal. Now you can easily see where an executable signal is going, because the signal path will light up. Here it is continuously being lit up because the event chip is constantly giving you executable signals. Now the great thing about executable signals is that you can attach as many signals as you want to the input, but you cannot attach multiple signals from an output. Now you might be wondering, how do you spread out one signal into multiple paths? Here are the two ways you can do that. First, if you just need one or two signals more, you can use the delay chip. With the delay chip, you can attach a signal to the run, put the delay at 0 seconds, and then you can attach two signals to the run and after delay. Now what's great about this, that even though to the naked eye The timing of the signals doesn't make a difference. For the computer, it can be huge and it can relieve CPU usage, but we'll be talking about that later. The second way is when you need to spread one signal into many. For that, you will need to create an event. Now, for you to use and create an event, you will need an event sender, an event definition, an event receiver. Now, first you need to define the event. So you can configure the event definition, give it a name, and if you want some other data to be transferred, you can configure that too. Then you need to configure the event sender into the event, so it will actually send the event you have selected. You can also configure who do you want the event to be sent to. Now lastly, you will need to configure the event receiver into the event. Then once you have that configured and selected, when you send an executable signal to the event sender, the event will activate and it'll send a signal to every event receiver that has been configured to that event. You can have as many event receivers for one event as you want, although I would be careful because this can cause a lot of CPU usage. Now I think it's a perfect time to tell you what I mean when I'm talking about CPU usage, network usage, and who the event is sent to. Now, it's probably easiest to visualize this. Let's say this is you. Now, CPU stands for Central Processing Unit, which means that CPU usage is the thing that is happening in one computer. If in your computer many executable signals are happening, your CPU usage will go up, but your friends won't. Now, the same thing goes for them. If your friend, so let's say computer 1, has high CPU usage, that will not affect you at all. Now, then there's also network heat. Network heat is the data that is being transferred between devices. For example, if you have variables that are synced, that means when one person's variable changes, they will all change. So, for that, every time your friend changes a variable, the variable's data that has been sent needs to be sent to you, so the data is same for you too. The best way to keep your CPU usage down and network heat down is to make sure all ongoing processes are divided among players. Certain processes being just local and some going through authority. This can also prevent contradicting data from being given. For example, most one-time signals like button presses can go through local, and then repeating like 30 Hz can go through authority. So select whose computer the signal goes through carefully. Now, that's mainly to make the network heat go down, but what about CPU usage? Well, for that you can slow down the process with delay chips. You can put a delay chip in between a process and it'll bring the CPU usage down. The delay time can be so short that the human eye won't notice it, so your process doesn't take forever. Now, I've been talking about locals and authorities and how you can choose which computer the signal goes through, but I haven't explained them yet. So, locally running signal means that the signal going in your computer. Same for your friend, but for him, his computer is the local computer. Now, room authority is the player selected in the room. Usually it's the first person to join the room. The room authority is usually used to process things like 30 Hz chips. Now, how can we choose which computer the signal goes through? Well, an executive signal is usually started locally by pressing a button or something different. But if you want to change the computer, you need to create an event. Now, remember how I talked about who to send the event to when configuring the event center chip? Yeah, so with that you can choose who it sends the signal to. Also, with chips like if player is room authority, you can basically weed out anybody who's not a room authority. Now we can move on to the second most important thing in CV2, which is variables. Now, variables are things that store data for us to later use. Now, as you can see, when I change a variable's input, the output will not change. To change the output or the data being stored in the variable, you will need an executable signal to go through the variable. The executable signal will change the data that is being stored in the variable to the current variable circuit's input. Now, variables have a feature in which if you have two variables that have the same name, the data that's stored in a variable is linked to its name. You can have multiple variable chips, but if they have the same name, the data being stored in those variables will remain the same. So when you switch the data from one variable chip, the other's outputs will also change. That's why when you have multiple variables, you will need to change their names. Now, when you're configuring a variable, you can also see there are a couple of options below the name. There's synced, cloud variable, and value. Now, value is the most simple. Value is the number that the variable outputs before the variable is changed by the room. It is the default value that the variable will output. Now, synced means that the variable will stay the same for everybody. So, when I change it, it changes for everybody. When my friend changes it, it will also change for me. Now, cloud variable, that means the variable will be the same even if you leave the room and come back to it. The variable will stay the same. It will remember value. Now, variables can contain many types of data. And here, as you can see, there are many different data types. Now, things on the right are list variables. Those you most likely won't have to worry about for a while. But basically they are just lists of different variables. But the things on the left, now these are the main data types you will come across. There are even more, but these ones you will come across mostly. Now the first data type that we have here is int. Int means that the number is a whole number. So 1, 2, 3, minus 1, minus 2, minus 3, all that. Second, we have float. Now float can contain decimals, so a float can be 1 or 1.1. Now then we have string, which basically means text. Then we have pool. Pool just means that something is on or off. Now the next data type is player. That means it's the ID of the player. Then we have Rec Room object, which is the same as player, but for objects. Then we have vector, which usually means a velocity, a direction, or a place in the world. Then we have quaternion. I would suggest you stay as far away from this as you can, because quaternions involve 4-dimensional math. And then finally we have color data. Now we can put all that we have learned today to the test. Here I have a bunch of chips. Now, what we want to do right now is when this button is pressed, it will send a signal that will go through authority, and for 1 second the piston will go up, it will stop, then reverse back down. Also, we want the how many times the button has been pressed by me and in total by others too. We want that to be recorded and displayed through texts. So, how would we do that? Now, first we will connect the button when pressed into the int variable changing. Then we will need to make the int variable go up by 1. So we'll need an add chip. We will connect that add chip, one of the inputs, to the variable's output, and the add chip's output into the variable's input, and then configure the other number to being 1. So it'll go up by 1. Then we can name the variable. Let's say the name can be times pressed. For this variable we won't be needing the synced button on, because the data that we want stored in this variable will be, for every player it will be different. Then we can go ahead and attach the int variable's executable output to the event sender, and then we can configure the event sender to the event, which I have already done, and I have already created an event definition. But we will need to configure in the event sender that we will be sending the signal to the room authority. Now I already have an event receiver configured to that event, so we can just go ahead and attach that to the delay chip. Then we can attach the delay chip's run output into the int variable. Then we can go ahead and do the same thing to this variable as we did the other, and make it go up by 1 every time. Then we can configure it, give it a name, let's say total. And then for this one we can put on synced, because we want the information of how many times it's been pressed for everyone, because anybody in the room can affect that number. Then we can go ahead and attach the int variable's executable output into the piston's play output. Then we can go ahead and attach the delay after delay output to the piston's stop input. Then we can go ahead and attach the piston's stop output into the delay on the right. Then put that delay's after delay into the piston's reverse. Then we just have to get the numbers to display on these texts. Now we can attach this first text to the piston's play executable output. Then we have to convert the int number into string using toString chip, and then we can attach that to the text. Then for the second text we will have to configure it and put synced off, because we want everybody to be able to see only their own number. Now we just have to attach that set text into that event sender, so it will update every time that event is sent. Then we just have to do the same thing to convert, attach this variable into toString chip, then attach that chip into text. And now everything should be working. Now, let's say we want a button that will reset how many times you have pressed the button. So we just copy the button and copy the variable. Then we can put the variable input as 0, attach that to the button, and attach the variable to the text. So it will update the text. This is the end of the video. Thank you for watching. Now, if you have any inventions or subjects you would like for me to cover, remember, comment them down below, and I'll see you guys next time.